All right, in 7.4, we're going to do the whole process of confidence intervals for proportions. So when you're constructing and interpreting a confidence interval, we follow a four-step process. So these are the four steps. We state the parameter you want to estimate and the confidence level. You plan, you identify the correct method, which is the confidence interval we're doing, and we check the two conditions that we've talked about, the random and the normal condition. If the conditions are met, we perform the calculations, and then conclude, we interpret our interval in the context of a problem. Confidence interval for a population proportion is referred to as a one-sample z-interval for p. Okay, so this is the inference test they're getting at right here when we identify the inference method. That's what we're using right now. Once you have a guess for the sample proportion, the formula for the margin of error can be solved to give the required sample size of n. So sometimes they want to ask us, well, if we want to be 90% confident and we want to be this close to the real thing, how many people should we sample? So we need to Okay, so I know you need to jump ahead in your notes to the first example, but I want to do this first example before we talk about the next formula. So Letitia wants to estimate what proportion of her school seniors plan to attend prom. She interviews a simple random sample of 50 of the 750 seniors in her school and finds that 36 of them plan to go to prom. Calculate and interpret a 90% confidence interval for the proportion of all seniors at Letitia's school who plan to go to prom. All right, so let's identify some things. Our sample size is 50. The X is the 36 that said they wanted to go to prom. Okay? 750 is the whole population. We don't need that. The confidence level is 90%. So remember, the first step is to state. So we need to state what we're trying to do. Since we want to estimate with 90% confidence, what we're trying to estimate the proportion of her school seniors who plan to attend. Okay? So we've identified what we're trying to do and what our confidence level is. Now plan, okay, what test are we going to use? We're going to use a one proportion z-test, and there's two conditions. We need to know, is it random? And we know it's random because it's a simple random sample where n is equal to 50. And then we ask, is it normal? And we check normal with our large counts test because of proportions. So n times p hat, which n is 50. P hat, let's do a little calculation. P hat is 36 out of 50, which is 0.72. So p hat times 0.72 gives me 36. And that's greater than or equal to 10. Then I do n times 1 minus times point, and that would be 14, and that's greater than or equal to 10, so that it passes our normal test. Now to do this, I'm going to write out my formula. So their p hat is 0.72 plus or minus, okay, margin of error. Remember our curve, we need to start with our z-star, right? And we did this before. This was 90, which meant this part was 0.05 and this part was 0.05. We put this in our calculator and we got a z-star value of 1.645 by using inverse norm and entering that area. So our z-star is 1.645, and then I showed my formula, p hat times 1 minus divided by our sample size is 50. Now, to make it simpler in the calculator, I'm just going to put all this in the calculator using the stat test. I'm going to go to stat, over to tests, and remember, go to A, one proportion z interval. X value was 36 out of 50. Our confidence level is 90%. And then I hit calculate. So if you look, our interval goes from 0.615 or 0.616 to 0.824. All right, there's our interval. So conclude is our sentence statement that interprets this. We say, we are 90% confident that the true proportion of seniors who plan to attend prom is between, convert this to percentages, 61.6% and 82.4%. Okay, that's what we do on conclude. So the state plan do conclude, that gives you an outline on how you answer these questions each time they're asked. Okay, if it says to calculate and interpret it, that means you got to do all 4 steps. All right, now, example, back to our notes. Sometimes they want us to calculate a sample size, okay, to figure out, how many people do they need to survey to get this close to the real value. Okay, if they know that they want their margin of error to be only like 1%, how many people should they have to ask? So this has a really complex formula, and I'm going to write it in simpler terms for you. It's going to look like this. So your sample size, and this is only for proportions. Okay, so make yourself a note. This is proportions only. Okay, you will do p hat times 1 minus p hat times z star over whatever the margin of error they wanted, and all of this business is squared. So you need to write this in your notes. It's not in your book. Write it in your notes, and I'm going to show you how to use it with the next example. Okay. Now, PTC is a substance that has a strong bitter taste for some people and is tasteless for others. The ability to taste PTC is inherited. About 75% of Americans can taste PTC, for example. Of Italians, sorry. 70% of Italians can taste it. You want to estimate the proportion of Americans of Italian descent who can taste PTC. How large a sample must you test to estimate the proportion of PTC tasters in this population within 0.04 with 90% confidence? All right, so you've got to think through some things, all right? What's my p hat in this problem? Well, that's the 75%, so it's 0.75. Okay, z star, we need to figure that out. The margin of error, what is the margin of error they want us to have? Within 4% or 0.04. All right, 90% confidence. Okay, remember our curve that we drew? We said 90% is the middle 90%, leaving 10% in the tails. So 5% is on the right, 5% is on the left. If we do inverse norm, 0.05, we get 1.645 for our z star. Okay, so if I use my formula, n equals 0.75 times 1 minus 0.75, and then z star is 1.645, and our margin of error is 0.04, and all of that needs to be squared. All right, so this is 0.75 times 0.25 times 41.125 squared it. Okay, so put this in my calculator. I square that times 0.75 times 0.25, 317.11. Now, when you do a sample size problem, you cannot leave your answer like this. You cannot survey 317.1 people. So what you're always going to do is round it up. So my real answer here is they need to survey 318 people. Need to be surveyed to get close to our actual value, back within 4% of our actual value. Okay? So pay attention. If it's proportions and you need sample size, you're going to use this formula. So let's look at number 3. Connecticut's located between New York and Boston. So baseball fans in the state typically root for either the Yankees or the Red Sox. In a recent poll of 803 randomly selected baseball fans in Connecticut, 44% of their favoring team was the Yankees. Construct and interpret a 95% confidence interval for the proportion of all baseball fans in Connecticut who would say their favorite team is the Yankees. All right, so we got to walk through our 4-step process. So we're going to state we want to estimate the true proportion of all baseball fans in Connecticut who are Yankee fans with what confidence level? We want 95% confidence level. All right, that's the first step. We plan it. So we're going to do a 1 proportion Z confidence interval. If our conditions are met. The first condition is random. Do we know if this is a random sample? It says poll of 803 randomly selected. Okay, simple random selected sample of 803. Okay, fans. Large counts. So I take 803 and I multiply it by p hat. Well, look at the problem. What is the p hat value? It's right there. It's the 0.44. So 803 times 0.44 is 353.32, and that's greater than or equal to 10, so far so good. Then we do 803 times 1 minus 0.44, and I get 449.68, greater than or equal to 10. So we passed both conditions, and I've shown my work for the conditions. Now the do step. All right, start with my point estimate, 0.44, plus or minus. Now we need to figure out what is Z star for a 95% confidence. Well, let's think it through. Draw the curve. 9.5 is in the middle. That means 5% is in the tails. If I split 5%, that's 0.025 right there. So I'm going to do inverse norm, 0.25, 0.1 in my calculator, and I'm going to get a Z star value. All right, so when I did that, I got 1.96. Okay, so that's my Z star. 1.96 times 0.44 times 1 minus 0.44 over 803. So I've written out my formula. Now let's see what is the interval the calculator is going to give me. That test. All right, so this asks us for X. We don't really know what X is. We just know that 44% of them said their favoring team was the Yankees. Well, you found 44% of them right here. Okay, so it's 353. So that's what you're going to use for your X. So I'm going to put in there 353 out of 803, and we're changing our confidence level to a 0.95. So we have 0.405 to 0.474. So there's our interval of values. So we do the conclude and we put some context on this, okay? What does this mean? It says we are 95% confident that the true proportions, or true proportion, of baseball fans in Connecticut favor the Yankees is between 40.5% and 47.4%. Okay? All 4 steps are needed. You got to do it. All right, example 3. Connecticut's located between New York and Boston. Same thing we just did. Okay, same problem stem. B says, based on this interval, let me just remind us what the interval was. It was 405 and 474. Okay, that was our interval of values. So 40.5% and 47.4%. Okay, So B says, based on this interval, is it plausible that the Yankee fans are a favorite team for a majority of the Connecticut baseball fans? Well, what does majority mean? Well, majority means greater than 50%. Well, our interval is not even at 50%, so it's not. So we would say because 50% or higher is not within the interval, it is not plausible that Yankee fans are a favorite team for the majority of Connecticut fans. Baseball fans. Okay, because 50 and higher is not even in our range of values, we know that's not a majority. All right, make sure you answer in context and or in a complete sentence. C says, if the researchers wanted to reduce the margin of error to at most 2%, okay, how many additional baseball fans do they need to randomly select? Okay, so this is loaded. Use p-hat value from the initial study. The p-hat value was 0.44. All right, so here comes that formula I showed you. So n is going to be p-hat times 1 minus p-hat. And our z-star value was 1.96 over our margin of error. They want it 2%, so convert that to decimal, 0.02. Okay, and let's see what value does this give us for a sample size. So I'm going to do 0.44 times 1 minus 0. Close that. Okay, times, I'm going to put parentheses, 1.96 divided by 0.02, and I'm going to square that part. Wow, that's a lot of people. Remember, we always round it up? So 2367. So that would be 2367 people. That's how many people they'd have to do. Well, it says how many additional fans do they need to randomly select? How many did they choose? They only chose 803. So I'm going to subtract the 803 to see how many additional fans do I need. 1564. So I will need 1564 additional people to be interviewed. Okay? So I know this is a long problem. I know there's lots of steps, but you are capable of doing a good job. We'll see you in class.